In this set of videos, we'll discuss C++ templates. First, let's take a look at function templates. So now, in order to motivate our discussion, let's consider a max function for two different data types. So as you can see, we have a max function for integers and a max function for doubles. You'll notice that the code is pretty much exactly the same. So if we want to find the max of two integers a and b, if a is greater than b, we just return a, and otherwise we return b. And the code is exactly the same for doubles. So now you see we've basically just duplicated the same code, and the only difference is the type. A better way to deal with this issue is with function templates. With function templates, we can define a function that takes any type of input that has the comparator defined on it. So now our max function, you'll see, uses the keyword template and angle brackets, type name, and then t, and the closing angle bracket. And now you'll notice that we are passing around our type as a parameter. So here we are passing in our type of input arguments by const reference, a and b, and the code is exactly the same. If the object of type t, which is a, is greater than b, then we return a, otherwise we return b. So let's see what this looks like when we actually use the code. If we want to call this function with integers, as we do in main, you can see that we're calling this on integers, we can name the function max, the name of the function, with the square angle brackets, and we put the type in. So here we have int, and we pass two ints to this function, 5 and 9. The compiler will implicitly make that call also. So those are both equivalent. Or if we want to take the max of two doubles, we can call the function max again, and within the angle brackets pass to it our type of double. So this is how we can do what we had done with two separate functions with a single function that uses templates in which the type of the arguments are passed as parameters. Now let's see what happens with classes. So let's think about how we can develop class templates, and let's look at another motivating example. So as you can see, we have two classes for lists, linked lists, and one is a list of integers and the other is a list of doubles. You'll notice that these classes are nearly identical with the exception of the type that is in the item struct, and because of that, the pointers that you have. So the type is determining what values and consequently what pointers are needed for the item structs. So if we looked at the implementation, for example, of pushback, they'd be essentially the same. We just create a new item for either our integer or double and add it to the end of the linked list. So this is motivating that instead of having two separate copies of the exact same code, which only difference is the type being passed in, we can use templates instead. So let's see what this looks like now. So here is an example of our list code, which is templatized. You'll notice that the first thing that we do is we have to templatize our struct. And in order to do that, you'll notice the keyword template, the angle bracket, the keyword type name, and t to be the variable for the type that we're passing in as a parameter. So here we can have whatever our type is of a value, and now you'll notice that our pointer to next is to an item of the same type. So you'll notice now we're passing the type to the pointer to the next item. Now when we declare the definition of our linked list class, now once again it's templateized. So we have template, angle brackets with the word type name T for whatever type is going to be passed as a parameter, and now you'll notice that we have a pointer to the head of the list, which has the parameter of the type of struct passed to it. Okay, so now you'll notice that when we actually instantiate our linked list in main, we actually have to pass the type of items we want contained on our linked list as a parameter. So for example, if we want a linked list of integers, we instantiate this by doing linked list, the name of the class, angle brackets, the type integer, and then the name of our list. Similarly, when we want doubles, we have a linked list, angle brackets, we pass the parameter double, and the name of our list. So my list is our list of integers, and my double list is our list of doubles. So the important thing to recognize is that it's the compiler that will generate the code necessary for the list of integers, and also separately for the list of doubles. So we don't have to duplicate all of the code. The compiler will do the work for us when we use templates. Now, just to reiterate, the key aspects of writing templatized code is whenever we want to use templates for a class or a struct, we precede the name of the class or struct with template, the angle brackets, type name, and T for the type. So we do this before the class, and we do this before the structs. Next, you'll notice that within the definition of our class, we then use the T for the substitution for the type that will be done. So you notice that we're doing that. So we can then use the type for the substitution. Then, when we have a class and we want to actually give the implementation of our functions, we have to use the scoping operator, but we also have to indicate that even these functions are templatized. So just to indicate that, so what we have to do is, you'll notice that before each function we put template, the angle brackets, type name T, to indicate that we're using template implementation for all of our functions. And now another detail is that when we have to put the name of the class in the scoping operator, we actually have to mention that we are passing the type as a parameter. So rather than just the name of the class linked list, you have to pass linked list, angle bracket, and T for the type, because the type is going to be passed as a parameter. So now you have to do this for all of the member functions when you're giving their implementations. Is you have to give the name of the class, angle brackets, and T for the type, and then the scoping operator.